Welcome to the final three-dimensional drawing video. We're now going to look at three mineral acids. This is our acid drawing section. It's very exciting, all right? So we're going to start here with phosphoric acid, all right? The first thing we're going to do is draw the Lewis structure. And so the way that acids work is these H's are actually attached to some oxygens. So we have phosphorus here with an O, 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 and an O. And those three hydrogens are attached to three different O's. So it looks something like this. Actually, I'm going to move this one to the side to give myself a little bit more room. All right? And as we fill in lone pairs, we get these two here, these two here, and we get three up here. All right? Several ways to do this, but I'm going to minimize formal charge. If I draw it like this, I have a minus charge on the top oxygen, and I have a plus charge on the phosphorus. But phosphorus being in the third period, if it's in period 3, set it free, so we're going to expand the octet. Looks something like this, all right? So let's go through this. When you see a structure like this, you're going to want to draw this middle one first. You're going to want to establish that geometry, all right? And I'm going to make it so that I don't have to worry about drawing a double bond coming out or into the board, all right? So phosphorus has 1, 2, 3, 4 bonding groups around it and no lone pairs. That gives us a tetrahedral shape. So we have P, there's our oxygen, there's another oxygen, O, and O. Excellent, right? Tetrahedral, awesome. This oxygen I'm going to put over here. It's got 2 lone pairs and 2 bonding groups. It's bent. And lo and behold, every other oxygen does the same. Now, as far as trying to draw these bonds in, like this oxygen has come out of the board at us, now we're putting a second bond on that, it gets very difficult to do. We don't want to worry about that, all right? I don't want you to worry about that. So we're just going to draw a line here to indicate that it's connected to the oxygen. There we go, phosphoric acid. Moving on to sulfuric acid. Sulfuric acid is a very common acid. It's also very strong because it's got these 2 hydrogens, which makes it even stronger. So if we draw something that looks like this, again, the H's are connected to the sulfur. So we have this, all right, this is a single bond over here. We're going to fill in our lone pairs, all right? But instead of doing formal charges on those 2 oxygens, what I'm going to do is I'm going to erase these lone pairs and I'm going to make a double bond to the sulfur for both of them. That eliminates formal charges. It also gives us a chance to see what happens when we have 2 double bonds on a single atom. So let's start with the middle, sulfur, 1, 2, 3, 4 bonding groups, no lone pairs. That means tetrahedral. So we have the O and the O, both in the plane of the board, all right? Now we're going to take this group, or this oxygen, have it coming out of the board. We get something that looks like this. And this oxygen going behind the board looking like this. Sulfuric acid, all right? So we have tetrahedral, bent, and bent. And finally, nitric acid. We did the nitrate ion 2 videos ago, if you remember, NO3-. This one has a hydrogen attached to one of those oxygens. So it's going to look, not the one with the double bond, it's going to look something like this. We have to have formal charges on the O and the N just because that's the nature of this drawing, all right? But if we look at nitrogen right now, it's got 1, 2, 3 bonding groups, no lone pairs. That gives us trigonal planar look. So we have something that looks like this. This oxygen here, whoops, forgot, that should have 2 lone pairs on it. So it's got 2 lone pairs, 2 bonding groups. That's a bent geometry. So now we get something that looks like this. And we have our trigonal planar bent geometry for nitric acid.